Today's topic is Allia'S Paradox. Now, Allia'S Paradox is a very significant theory or a very significant paradox, and it is named after the French economist Maurice Allia'S. It is a very well-known theory in the or very well-known problem in the decision theory and the behavioral economics. So basically, this theory, before diving into this theory, before diving into the Allia'S paradox, at first I want to tell you about the expected utility theory, because if you don't know the expected utility theory, then the Allia'S paradox you will not be able to know this Allia'S paradox. So expected utility theory at first. Now, expected utility theory tells us that suppose you have two options, and suppose you have two options, one is option A and one is option B, and if you choose option A, you might get 5 million rupees or $5 million, or you might get suppose you might get or you might get nothing. Okay, so you might get $0. So there is 90% chance that you will get $5 million, and there is 10% chance that you will get nothing. And you have another option, that is option B, and in the option B it is saying that suppose you will get $6 million and you will get $3 million. Okay, or if I suppose you may get $3 million and you may get $4 million. Now $4 million or $3 million. Now there is suppose there is 80% chance that you might get $4 million, and there is 20% chance that you might get $3 million. And suppose the expected utility. Now if I talk about the expected utility, which option will you choose? If you see that in case of an individual always watches the higher utility. Higher utility is being observed by the individual, and the higher utility can be obtained, or a higher utility can be obviously this will give you the higher utility. The second option, B option, if you calculate the utility, in case you may get $4 million, and another case you may get $3 million, but there is no chance that you are going to lose everything or you will not get anything. So this case will actually give you the higher utility. So this expected utility theory tells us that the higher utility, or the option that have higher utility, although it's a risky option, but individuals choose that option. Individuals choose this risky option after comparing their expected utilities. Even the option is risky, but individuals will choose this. Now if I go to the paradox, so suppose we have two scenarios, scenario 1 and we have another scenario. In the scenario 2, I am going to talk about the scenario 2 later. At first, scenario 1. Now in the scenario 1 you have two options, option A1 and option B1. In option A1, if you choose, you will get a guarantee $1 million. 1 million guarantee, no chance of losing. It is 100% sure that you will get $1 million. And in case of B1, you may get 1 million, but there is 89% chance that you will get 1 million, 10% chance that you will get 5 million, and remaining 1% chance that you will get nothing. That is the first situation. Now we are going to the second situation, situation 2, or scenario 2, scenario 2, or in the scenario 2 you have given two options, A2 and B2. In the option A2, if you choose, there is a chance that you will win $1 million, but this 1 million you can win, the chance of winning this $1 million is 11%. Okay, you may choose and there is 89% chance that you will win nothing, 0 million or 0, you will win nothing, that is 89%. And in B2, if you choose B2, you may win 5 million, but the chance of winning 5 million is only 10%. And the chance of winning 10% winning of 5 million, yes, and 0 million or nothing, you will win nothing, that will be for 90% cases. Now when we take this example and when we take these scenarios and when we empirically go to the data collection, when we ask people that what will they choose, so this empirical data collection actually gives us the information that obviously in the first scenario the people will choose A1 over B1 because they are 100% sure that they are getting 1 million, so obviously they will choose A1. But in the second scenario, people are not choosing A2, people are choosing B2. Why are they choosing B2? Because in the B2 there is a higher chance that there is a higher valuation. They are willing to take the risk because the valuation is high, $5 million, they can actually get $5 million, and that's why they are actually willing to take the risk. So now if we go by the expected utility theory, what is expected utility? Expected utility is basically summation of Px. Or I may write it as summation of P into U of X. Here if I write that if I write it in a modified version, suppose if I want to write it expected utility of a game or of a gamble equals to summation P I U of Xi. Here G is denoting gamble and Pi is denoting probabilities and Xi is denoting outcomes. Now I want to set this with respect to the scenario 1 at first. So let us calculate the scenario 1. In case of scenario 1, we have two options in scenario 1, A1 and B1. And let me calculate what will be the expected utility of A1. So for that I require the probabilities. Now in case of A1, the probabilities is you may get 100%. Obviously in the probability is 100%. That is, you will get $1 million. Okay. So how can I write the probability? I can write the probability as before setting this, let me write that I am taking some values for accepted or for granted. And what are those values? I am taking those values as this is basically the part of the mathematical model that I am taking the values as utility of 0. That means when you are not winning anything, you are winning 0, and then that will be equal to 0. When you are winning suppose 5 million, then the probability is 3. And when you are winning the 1 million, then the not the probability, then the expected utility will be equal to 1. So these are the three things. Utility of when you are winning 5 million is 3. Utility when you are winning not E, it is supposed to be given as U. Utility when you are winning 1 million is equal to 1, and utility when you are winning nothing is equals to 0. So now if I want to calculate expected utility of A1, now expected utility of A1 is basically in the A1 the person is getting 1 million for sure, right? So that means it is basically when you are calculating A1, it will be utility when the person is winning 1 million, because he is going to win for sure, and we have to multiply it with the probability. Now what will be the value of probability? He is winning for sure, and what is the probability of a sure event? It is 1. That is, if you even take 100%, that will be 1, right? So it will just remain utility of 1 million, that is equal to 1. So I am taking it as 1. Now I want to calculate the expected utility of the option B1. Now in case of B1, the person might get 1 million, and the person winning 1 million, that is utility of 1 million. What is the probability of that the person is winning 1 million is 89%, means 0.89, plus the person might get 5 million, but the chances of 5 million winning 5 million is 10%. That means 0.10 is the probability, and the person in that probability, the person might get 5 million, and the person might get, here I am adding it here, and the person might get nothing, and the chances of getting nothing is 1%. So that means 0.01 into expected utility of 0, or you may write utility of 0, sorry, not expected utility, utility of equals to 0. Now if we substitute the values here, what will we get? We will get expected utility of B1 equals to, here as you can see that this value 0.89 into utility of winning 1 million, it is nothing but 3, it is nothing but 1. What is the utility of winning 1 million is 1, so we may substitute here 1, here we will substitute 3, here we will substitute 0 in place of utility of winning 0 or nothing. So we will write it as 1 into 0.89, this place can be substituted, this entire thing can be substituted as 1, this entire thing can be substituted as 3. So we may multiply 0.89 with 1, 0.89 multiplied by 1, plus we may multiply 0.10 with 3, and the result will be 1.19. Now let us calculate the scenario 2, situation 2 or scenario 2. In the scenario 2, expected utility of A2, let us calculate the expected utility of A2. That will be nothing but the person might get 1 million. Let me see. In scenario 2, the person will get 1 million for 11% of the time, and 0 million for 89% of the time. So we will just write utility of winning 1 million, and how many times it will occur? It will occur for 11%, that means 0.11, and the person might get nothing, and that will occur for 89% of the time. This can be written as 1 into 0.11, this can be written as 0 into 0.89, so the value becomes 0.11. Similarly, expected utility of B2 in the situation or in the scenario 2, that will be the person might get 3 million for 10% of the time, 10% is 0.10, and the person can get nothing, that is 0 for 90% of the time, so probability is 0.90. So if we calculate it, it will be 0.3. Now why the paradox is arising? Here the question is why the paradox. Now I will explain that answer, that why the paradox is arising. You have to understand that here from. In case of scenario 1, what is the expected utility? Let us consider the scenario 1. Scenario 1. What is happening in scenario 1? Expected utility of A1 and expected utility of B1. As you can see, expected utility of A1 is nothing but 1, and expected utility of B1 is nothing but, if we have calculated, yes, we have calculated it, is 1.19. So which one is greater? Obviously expected utility of B1 is greater, but the person is choosing expected utility, the person is choosing A1, because the person is very much sure that he will win. If he chooses B1, he might win more than 1 million. He might win 3 million, right? Because in the option B, in option B1, the person has the chance of winning 3 million, that is 10%. The person might choose win 1 million for 89% and might win nothing for only 0% of the occurrences. But still the person is sure that he will win 1 million for 100% of the time in situation 1, so he chooses A1 over B1. Although expected utility of A1 is less than expected utility of B1, still the person chooses A1 over B1. Right? So, expected utility theory tells us that the person always chooses the option which has greater utility. Right? As I have told here also, that expected utility theory, which is written here, that if I have greater expected utility in this portion B, I will obviously choose B. But here the person is not choosing B. Generically, the person is choosing A1 because the person is risk averse here. Because the person is risk averse. So he is actually avoiding the risk here. Risk averse. Now, situation 2. In case of situation 2, the person might choose A2 or the person might choose B2. Now let us calculate the expected utility of A2 and expected utility of B2. In case of A2, the person is getting 0.11, and in case of B2, the person is getting the expected utility of 0.3. So A2 is 0.11, it is B2 is 0.3 or 0.30. Which one is greater? Obviously B2 is greater. Here the person is choosing B2. The person is choosing B2 because of the higher expected utility. So here the person has become risk seeker. So here the person has become risk seeker and he is running behind the higher expected utility. As you can see, A2 and B2, if you compare, in A2 the person might get 1 million for 11% of the time, but in B2 the person might get 5 million, but it is for only 10% of the time. So 1% is less. I mean, in case of A2, the person winning nothing, the chances of that event is 89%. In case of B2, the person winning nothing, the chances of that event is 90%. Still the person is choosing B2. Despite of the fact that the chances of winning nothing is more in B2, the person is still choosing B2 and willing to take risks because of the higher reward of 5 million. So that's how the expected utility theory doesn't hold here, because here the person was choosing the utility which was actually here the person was not choosing the higher utility which was supposed to be done. The person was choosing lower expected utility, because of that the person was risk averse and he was sure about winning the award. But here the person has become risk taker, or the person has become a risk seeker, right? So risk seeker person actually chooses B2, because in the B2 expected utility is higher, right? And in the expectation of higher reward he chooses B2. So this is the Allia'S paradox.